So we know from the previous module how we work around composite shapes, which are made up of more than one shape, or it's one shape but you can split it up into more than one shape to make it easy for you to calculate area or volume. Similarly, you would use the same approach here to get the volume of the cross-sectional area. You would have to divide it into two areas. Get the area of this upright rectangular and a triangle. That works out to one cross-sectional area, and which you slot it in until you reach the end of 23 meters. So you get area 1 and area 2 and you put them together as one area of the cross-sectional area, which is 256 meters squared. And then to calculate volume, you just multiply by the length, which is 23, and you get the volume. Another example for this one, again, it's another composite figure. So you divide it into two areas as well. You get the area 1 and area 2. You put them together and you get one area, which is now the cross-sectional area, and then you slot it into the object or simply multiply by length and you get volume. Another three-dimensional object, which is a cylinder, which is a cone in relation to a cylinder, you would have to, if the cylinder has the same diameter as the cone and the same height, you will have to figure out how much of the contents in the cone can go into the cylinder as the one approach. So if you feel that it's not drawn accurately, I have to fix up these lines. So that, empty it into a cylinder, fill it up again, empty it into a cylinder, fill it up again, empty it into a cylinder. It goes 3 times. By definition, what this means is for a cone that has the same diameter as the cylinder and the same length, the contents of this cone go into the cylinder 3 times. That means the cone is 1/3. If it's full, it's 1/3 of a cylinder. That already says if you were to calculate the volume of a cone, somewhere it will need to have 1/3 as part of the formula. Let's see that, because it goes 3 times, it's 1/3 the cylinder. This shows that the cylinder has 3 times the volume of a cone with the same height and radius. So from previously, we know that the formula for a cylinder was pi radius squared height. And now that we know that the cone goes 3 times into a cylinder, which is 1/3 of a cylinder, what is the formula for the volume of a cone? It works out to be 1/3 of this, because this is the cylinder. So 1/3 of that is the formula for calculating the volume of the cone. And at this point, we know how to calculate the area of the circle or the volume. After you get the volume and then you multiply by 1/3, that gives you the volume of a cone. Putting numbers to it, now that we know the formula is 1/3 of the cylinder, volume of a cylinder, from the previous example we know that pi is 3.14, and then we are given 6 as the radius, but it's squared, so that is multiplied by 6, or simply 6, and then you put a little 2 here, which indicates squared, because for pi radius squared, multiplied by 9, which is the height, and you get the volume of a cone. Another example would be with the different measurements, same approach, and you get the volume. So in summary, you can calculate, we have calculated the volume of a cuboid given by that formula: length, base, and height. For the cylinder, pi radius squared height, as we've just seen now. For a triangular prism, it will be half base by height, which is the area of a triangle, then multiplied by length, which is that one. And for a cone, it will be 1/3 of the cylinder, and this is the cylinder, this part, and then 1/3 of it. This should be easy for you guys to get free marks here. That is the end of volume. Cheers, guys.